Good afternoon, everybody, and welcome to Robot Build Log number 2. This one is a little different. I just got this program OBS, and I'm going to be using it to record this screen. And today I'm also going to show you how I'm using Microsoft's OneNote to help organize myself. So this whole video will be done screen recorded from my computer. Alright, so this is Microsoft OneNote. I haven't used it too much, just dabbled in it here and there, but it's actually really cool for helping organize everything. You can type stuff in, you can add pictures, checklists, different notes and stuff. Got a bunch of tabs you can do, and then you can add just sections to it on the side. It's actually really versatile and very intuitive to use. How I've got this set up is I think I can do like an overview page with kind of everything I'm working on, concepts, research, software and hardware. I actually haven't got too far into that yet. I just kind of jumped right into my build log videos. So I set this all up after I did build log number 1, but I just took kind of my notes and put them in here just for reference. And number 2 is one we're doing now, and I've already actually got number 3 done because I was a little late in getting this number 2 video out. So here we are, Robot Build Log number 2, and this one's about PC to Raspberry Pi 3 communication. I knew that if I couldn't communicate from my computer to this machine in my house, then well, it's not going to work at all. That's the most important thing, is being able to control it remotely. So I figured, okay, start small. That's my creation philosophy here. Dream big, start small. And attack the project in sections to make it manageable. So what I did was I started with just blinking an LED, not over the internet, not anything, just blink the LED on my Arduino to kind of get familiar and play with it again, which I was able to do. Then I said, okay, I need to make this little LED blink from the Raspberry Pi to the Arduino. And how I did that was using GPIO pins. I outputted just a 5-volt signal from one of the GPIO pins on the Raspberry Pi and had it input into the Arduino. And when it sensed that, it said, hey, there's a voltage on this pin, light up this LED. And that just kind of, to me, represents being able to send a command to a motor or an arm or even some kind of sensor control or something like that. That's kind of how I planned on setting all that up. Now actually I think I'll probably use those other interfaces like I was talking about in the last video, maybe SPI or something like that. I already kind of forget. The GPIO pin was just kind of playing around. Anyway, what I did find out when I was doing that little experiment was that Raspberry Pi puts out 3.3 volts and the Arduino uses 5. So I did order a logic converter. It's on its way now. So the next step was to send a Java message from the laptop to the Raspberry Pi, and that was a lot more complicated than I expected it to be. Like in the last video I mentioned, I had to look at the sockets or something like that. Well, I've actually been dabbling in Java even before this project, and I was following this guy called the New Boston, and he does all these Java and actually every kind of programming video you can think of. He does walkthroughs on them. Anyway, he actually has one in his advanced Java tutorial section on setting up this whole instant messenger application. He wrote it and teaches you how to do it, and it's about, I don't know, almost 20 videos I think from start to finish. So I went through all of those, and in the end you end up with this little instant messaging program. This is kind of what it looks like here. There's a client and a server, and you run them on different computers, and you can send a message from one person to the next. And my whole plan was I'll use that program, but instead of sending messages, I will send an array of integers, and each integer can represent, okay, forward speed, turn left, turn right, arm up, arm down, whatever it is. So I planned on adapting Bucky's instant messaging program to update an array of values and strings instead of updating the big chat window. And I was successful in doing that. I also want to adapt the GUI to be more of a control GUI than a message program. And I may want to build a standalone controller to operate the robot, or look into what video game controls may be translatable to real life. So I was thinking, how am I going to actually control this physical thing with a keyboard and, you know, just buttons? Is it going to be intuitive? And I was thinking, okay, well, maybe I can play some video games and see how you control it. I also started brainstorming. I've got this touchscreen for the Raspberry Pi that I'm currently using now as a display, and I'm like, well, maybe I could 3D print a whole controller around it with, you know, a couple joysticks and buttons and triggers or whatever, even use gyro sensors and stuff like that, and build this kind of more, I don't know, like pretty cool controller where I can watch the video from the cameras while controlling it all almost like a video game, and it would be portable too. So I think that would be really cool. Anyway, that was all just kind of in my head. Actual testing, so I was trying to set up this instant messaging program while I was up at work, and we're on like a private network there. It's all set up by the IT guys. I can't mess around with stuff, so while I was able to get this program running on my own computer, as soon as I tried to hook it up in the network, it was not working. I did not have any administrator permissions to set up port forwarding, which is what I found I needed to do, and pretty much all work stopped there until today, really, and that was about a week ago. So where am I at here? Yep, I'll set it up in home. So I've got a few pictures here. I did get the program working properly. I ordered some fun stuff and I did some drive system brainstorming. So here you can see this is like the program, like I showed you guys. You are now connected. This is the client, this is the server, and I actually was happy. Like, I noticed I had made a mistake in the code here. It wasn't copying some messages properly, and I was able to recognize that and go back in the code and fix it myself, because I had learned enough to actually go back and do that. What else have I got here? So I ordered a camera. This one actually plugs right into the Raspberry Pi board. And this is going to be like a little backup camera. It's just a little USB thing. I may or may not use it, but it was $8, so whatever. This is the 5-volt, I guess, logic converter. So on one side, 3.3 volt signals will go in, and it'll just instantly output them at 5.5 volt. And they go both ways. So Arduino can talk to Raspberry Pi can talk to Arduino. It just works. Now for this robot in my house, I have stairs. And I think it would be really cool if it could go up and down the stairs, and so I can just get all over the place, right? And I'm thinking, how am I going to do that? Robots are actually not good at navigating stairs. You either need like a biped robot, something with legs that walks like a human, or you can use wheels, or you can use tracks. And the problem is my stairs kind of go down halfway and then turn around and go down the other half. So it can't be too long. But I figured out that the average stair tread is 24 inches. I have to actually measure my house, but that means that I need a minimum track distance of 24 inches. So that was a little bit of brainstorming I was doing, and then I got into looking at this other system called Rocker Bogey, and you'll recognize that because it's on pretty much it's on the Curiosity and the Opportunity rover, like the 2 Mars rovers. They use these systems because they can actually crawl right up over rocks really well, and I think it helps keep like the payload level, kind of as you can see here. The only problem with that is you need to drive each wheel individually, and after a lot of contemplation, I think I'm just going to go with tracks, because I don't want to have to A, buy 6 different motors, and B, control them all. That's just a little too much for me. Plus you got to get into like steering and all that kind of stuff. So I think the easiest way is just a couple tracks. And I was also thinking, so it would be really cool if this thing could kind of go up and down. It could like squat down if it needed to, or if it could raise up to reach stuff, since I plan on having a little arm on it. So this is the kind of little suspension system I designed. I might try to make something like that work. This could be like a controllable height piston, if you will, or a linear actuator. And then I was thinking too, for the front of it, like I could have the tracks kind of go up and down, transform a little bit. So when you're normally driving around, they would be up, and that would give you a shorter track base, if you will. It would probably help steering a little bit better. so you're not sliding the entire length of all the tracks on the floor just every time you need to make a turn. But it can still go down to get that extra 24 inches to spread across at least 2 stair steps when it's trying to go up and down the stairs. So I was looking up some tracks, and I haven't found anything I like, but you can get these pretty cheap, model tank tracks and stuff on the internet. This isn't exactly a tread pattern I want to use, but they are cheap and they're expandable, so I can just make it fit to whoever I need. So like I said, I've actually got number 3, Bucky's instant messenger video ready to go here. So I'm going to do that one up, and I will see you guys in the next video. Oh, and my friend Ange told me, tell you guys, don't forget to like and subscribe if you want. I'm just an internet guy, I'm not the cops, so do whatever you want. Have a good one, guys. See ya.